So in this question, you've got a velocity graph over time. So what time is the acceleration of the particle zero? So acceleration of the particle would be zero when the velocity is not changing. So if you look at the first one, our velocity is the same when in the first second. So and then then the velocity starts to get increase, but then it stops again. Then the velocity starts to decrease until it stops again, and then it goes through, it increases to 6, and then starts to be constant velocity again. So if the velocity is not changing, that means there's no acceleration being applied. So velocity would increase when there's a positive acceleration. It'll decrease when there's a negative acceleration or some sort of retardation happening on it. So we can see from the start to 1 second, there's no acceleration. At 3, there's no acceleration because it stops accelerating and starts to decelerate. And then at 5, it's going to be 0 again. And we could probably say after 6 at that point there as well. What time is acceleration the greatest? So what we're looking at is between 4 and 5. It's the steepest it will ever be. So that's the greatest gradients of the curve is between those 2 points. So that's why we can say the acceleration is greatest there. Even if it was really decelerating, it's slowing down. But the acceleration, the force that's applied, is the greatest there. And at what time is the particle at rest? So at 4.5 seconds and 5.5 seconds, the particle's at rest because the velocity is 0 at that point. So then the velocity is 0, then it's going to be at rest. So keep that in mind when you see at rest, particle velocity is 0. So in question 3, you've got a car, drives off, constant rate. So these are all constants, and reaches 30 meters per second, travels at a speed for 5 seconds, then slows down at a constant speed for 5 seconds until it's traveling at 20, and then it travels at that speed for 15 seconds. So there's the graph that describes that question, or that explanation. So if we want to look at the distance travelled by the car on a separate diagram, so in the first 10 seconds it travels that far, and you can see the numbers. After 15 seconds it's travelled 300 meters, then 400, then 5, and 700 all up. So the way we do that is to break it down and look at our areas under the curve, because the area under the curve will give us the integration you could do, but it's the area on this curve which gives us those distances. So the area under this curve would be, I think it's 150 meters, and then the next part would be the rectangle here, then the trapezium, and then the rectangle, and that's how we get all these points on these lines, by finding the area under this curve, and that's going to give us the distance that's travelled, because if we find the area, that goes back to the distance as a function of time t.